Hello, everyone. My name is Ilia Gusakov, and today, together with Alex Kaminsky, I will be presenting in this webinar, which is a quick introduction to the processing of electrical resistivity data in the ZondRes2D program. If you have any questions during the webinar, please post them in the chat, and at the end, we will try to answer them. So let me start with the presentation. So I hope I'm sharing my screen now. If not, please let me know. And I would like to start with modeling. Modeling is an important part of the planning stage of a resistivity survey. By creating geoelectrical models based on the expected geology of our job site, we can assess performance of various arrays and survey parameters. We can assess signal levels, and finally, we can see how the inversion will recover our model based on the calculated resistivity data. Now, to start modeling, first we need to create a measurement system. There are two options in the program. Using this create synthetic survey command, we can create a ground-based measurement system. And another option is to create a cross-hole measurement system. I will go with the ground-based measurement system. So here in this dialog box, we can specify the number of electrodes we want to use for our survey. We can specify the spacing between the electrodes. And also, if we want to do roll-along measurements, these two settings will specify the roll-along parameters. In this drop-down list, we can select an array type for the survey, and also for some of them select a subarray, which in the case of the pole-dipole array is forward, reverse, or both arrays. I will go with a pole-dipole array in the forward and reverse modification. In the worksheet tab here, this on the top is the schematic of our data set. It shows the position of our data points as they will appear on the pseudo section. And here is our measurement system in a tabular form. So the left column here lists all possible distances between the current electrode and the center of the potential dipole. And here we can select add data measurement system or remove some data points. So these measurement data points are grouped in the columns based on the size of the potential dipole. So the measurement system is fully customizable. We can remove data points or we can add some of them. Well, for example, let me remove some data points and create a new measurement system. So usually near the surface, we want a denser grid, and then going deeper, we don't really need the grid to be so dense because the resolution of the method decreases with depth. You can add some overlapping measurements, or you can go without the overlaps. And when you create the measurement system, after you configure the design, you can then save it into a measurement protocol file You can save the measurement protocol in most commonly used formats like Syscall, ABAM, and others, and then upload this protocol into your instrument and then use it for your survey. So let's create this measurement system. The next dialog box suggests us to configure our model mesh. Usually the settings that the program suggests, they work quite well in most cases, but if you want, you can modify it by, for example, increasing the number of layers or making the denser grid or making it less dense. But in most cases, again, the suggested settings are quite adequate. The only thing that I would recommend for modeling, for solving the forward problem, we recommend to have at least one intermediate node between the electrodes for more accurate solution. So I will go with all the default settings. And right away, we see on the top here is the pseudo section with the resistivity values calculated for our model here in the bottom. As you can see, the model is already trimmed. These areas in the corners, the areas of lower sensitivity are trimmed so that the model resembles the pseudo section. But for modeling, it's better to disable this option and use it only for the inversion. So I will display the whole model here. And also at any time, you can go back to the mesh constructor dialog box, and if you need to modify your mesh, you can do it. Also, you can modify your mesh interactively. For example, you can make it less dense or more dense, both in vertical and horizontal directions, like so. And also there is an option to add any grid lines anywhere you like by using these tools here. So this mesh is fully customizable. There are three modeling modes in the program. So this is the mesh modeling mode, where you can create a model by changing the values for resistivity for all these cells. Then another modeling mode, which is selected by clicking on these icons here on the toolbar. So this is a layered modeling mode, where the subsurface is represented by a set of discrete layers. And the third modeling mode is the polygonal modeling mode. I will go back to the polygonal modeling mode later, but first let's create some model here in the mesh mode. You can bring up a floating toolbar with various selection tools, or you can just use this drop down list here in the modeling space to select these selection tools. For example, there is rectangular selection tool, using which you can select a range of cells with this rectangular selection, and then you can change the resistivity for the whole range of cells. There's another option, is the circular or elliptical selection tool, which work like this. And finally, another one is just like a free form selection, which works like this. And right away, after you change the resistivities in the model, you can calculate the forward problem by pressing on this icon on the toolbar. So this is the pseudo section calculated from our model that I just created. This pseudo section doesn't look pretty, because it shows data for both forward and reverse arrays, but we can deselect for say forward array and show the data only for the reverse array like this. And also you can move your selections here in the model space and modify it in any way, then just recalculate your theoretical data. And in the polygonal modeling mode, you can create models by plotting polygons like this. And what you currently see here in the model space in the background, this is not a model, this is a background. This was left from our mesh modeling mode. We can remove this background and just plot the polygons on a blank sheet, or we can actually upload any image in the background and use it as a background. For example, if you have a geological cross-section that you want to plot over, you can upload an image and just plot your polygons over this background image. I don't have a geological cross-section, so I'll just show how to upload a seismic cross-section in the background. So this is just like a random seismic section that I just uploaded, and then we can plot polygons just using these tools in the floating toolbar, like so. I'll just I'll plot a few polygons so you have an idea how this works. I'll plot a couple of them, something like this, and then you can specify the resistivities for these polygons. Like so, and then again, at any time, you can just solve the forward problem and see how this will look like on the pseudo section. And finally, after we create our model and we solve the forward problem, to test the inversion algorithms on this data, we need to save this calculated data and then open it again in the program as observed data. We have an option to add some artificial noise to our data set, so it will be sort of closer to real life. To do this, we need to activate this option in the import export submenu, save synthetic data with noise. And after that, we can save this data. There are two options for saving the calculated data. We can save it as just calculated data, only the calculated data, and then another option is to save the calculated data with the model. I will use the second option. So now in this dialog box, the program prompts us to add some noise into our calculated data. In this input box in the top, we need to specify the current value, which we estimate typically it's around 200 milliamperes. And then we need to add the noise. For example, I will add maybe 1 millivolt for this. Now we can open this saved calculated data and run the inversion on it. So here, this is our model that we created, and before running inversion, we need to clear this model, but first I will save this model into the buffer so that we can compare the initial model and the inversion model. Okay, and so I'm going to clear this model, and I will also remove this background image because we don't need it, like this. So we now have the clear model. And another way to display your data is to show the graphic plots. So here in the center, in the middle of the screen, this is the original calculated data. And on the top, the data that we saved with some random noise added. It doesn't seem to be a lot of noise here, although here and there, in this portion, you can see there is some differences between the theoretical response and the data that we have saved. But overall, it's not a strong noise here. So now we can run the inversion on this data set. I will just, for the inversion, there are inversion settings in this program setup dialog box where you can specify the inversion algorithm you want to use and select the number of iterations. I will go with 10 iterations. And also you can set the variation limits for the resistivity. And there are also some additional settings here in the model tab. I'll just, there's a lot of settings for fine adjustment of the inversion algorithm. Another set of settings is here in the inversion submenu. I will not go through all the settings because this webinar is too short to speak about all of them. So I will just run the inversion now. So now we have this inversion model that we can now again save into the buffer, and then we can compare the two models. On the top, this is the initial model that we created, and on the bottom here, this is the inversion model. So this is the basic routine for modeling. Now let's have a look at some real data examples. In Zond, you can open data file in various formats. For example, it supports formats from most popular equipment manufacturers, some such as EBM, AGI, Syscal, and others. And also you can open the data saved in the ZondRes2D in program format. And also there is an option to open several data files, because sometimes some instruments, they will save multiple data files. For example, when you do the survey using the same array but different array types, this might be saved in two different files. And also sometimes when doing roll-along surveys, those sections will also be saved into separate files. And here in this program, you can combine all the data into one project. So here I have two files. The first one was collected using a Schlumberger array, and the second one was collected using the same array, but using a dipole-dipole array. So I will select these two files and open them. So the program prompts us to enter the electrode shift for roll-along. We don't have that. And also the position of the first electrode. And again, this is the mesh constructor, and I will just go with all the default settings. And as you can see, the files I just opened, they already have the topography in them. So this the model is already plotted with topography. Now, to check our data, we use the quality control module, where you can see all the data plotted in the form of graphs, and also there's an option to display the pseudo section. And here in the settings tab on the left, we can see that indeed these data were collected using two different arrays. First is the ABMN, which is dipole-dipole array, and the second one is symmetrical, which is either Wenner or Schlumberger array. And you can select or deselect these arrays and look at these data separately, or also, well, you can perform the inversion on both data set, invert them all together, or you have an option to invert them separately. For example, I will show how to do the separate inversion. For example, I will deselect one of the arrays, and I'll just run the inversion on one of them. So this is our inversion result. I will save it again into the buffer, then go back to the quality control module. And now I will select the second array and run the inversion on the second data set. For this, I'll clear this model and run the inversion again. And we can now save this inversion model to the buffer as well and compare these two inversion models. So you can see this is the, on the top here, this is the Schlumberger array, and on the bottom, this is the inversion result for the dipole-dipole array. If your data are not in any of the supported formats, there is an option to import your data into the program from a text file or Excel spreadsheet. For this, your data needs to be grouped in columns based on the coordinates of the electrodes, and also a separate column for the measured resistance. So let's see how this is done. I'm using this command here, import data from text or Excel file. And actually, I don't have a text file for this, but I will just open a file saved in the ZondRes2D format to show how it's done. It will be just the same. So all the data are grouped in columns, and now we just need to specify the headers for the columns. For example, for this data set, there's the coordinate of the second current electrode, and there are coordinates for the two potential electrodes. And these columns here are vertical coordinates that we don't have. And finally, this column is the measured resistivity. So once we choose the correct headers for the columns, we can click OK and upload our data. Now, for topography, there are a few ways to import the topography data into your model. But probably the easiest way is to use this topography editor dialog box, where you can just input the elevation values for all the electrodes. And the easiest way to do this is just to copy the whole column from say a spreadsheet. This is what I'm doing now. I'll just copy column from a spreadsheet and then just paste it into the elevation column using the Control-V key combination. So click OK, and now we see there is the topography for our model. But if you don't want to use topography, you can also remove it. Now, for usually when we first open our data set, we want to do some quality control. This is done in this quality control module, which I already shown before. Now let's have a closer look at it. So here, all our data are plotted in the form of graphs, which are, all the data points are grouped based on some sorting parameter. The sorting parameter is selected in the settings tab. So we can sort our data based on the geometrical factor or pseudo depth. This is the default option. Also, we can sort them by position of the current electrode or electrodes. This is how it looks like with this option. But since, as you can see, this is the pole-dipole array, for this type of array, the best way to display your data is to plot it using the sorting by the size of the potential dipole. So here you can see that using this type of sorting, all the graphs here, the signal on all the graphs, the signal naturally drops with the increased distance between the current electrode and the center of the potential dipole. So in this type of plot, it is easy to see if there are any outliers in our data. So we can select only one graph to display, and then we can just scroll through all the data using the mouse wheel on this legend here, or we can select several graphs and again scroll through all of them. And as you can see, with large spacings between the current electrode and the potential dipole, there are some data points that do not look right. They seem like outlying a bit. Usually the inversion algorithm can deal well enough with the outliers if they're sporadic. But as you can see here, we have a trend, and the trend is not good. So it's better to remove these points. So what I'm going to do, I will just select these points using this selection tool. I'll just scroll through all the data, and I will deselect these points real quick. Yes, as you can see, there are quite a few of them. By the looks of them, they seem to be there seem to be some problem with equipment, maybe. So now you can display again the whole data set, and there are two options. You can just remove these points from the inversion by clicking on this button here, but this data will still be stored in the project. Or we can simply delete these bad data points. This is what I'm going to do. I'm going to remove these points, and as you can see, some points were removed from the pseudo section. We can go to the quality control model again and see if there's any bad data points that we missed. It doesn't look so all looks smooth now. And now we can run the inversion on this data set. So for the inversion models, we can apply this cutting to cut the areas of low sensitivity in our data. Also, you can display the model. This is the block section display. We can display it as a smooth interpolated section. And also we can display it as a contour section. And the inversion misfit is displayed at the bottom in the status bar. This box here shows the RMS error of the inversion. Currently, it's 1.3, which is a good value. It indicates that the data quality is very good. But if so, for some reason we don't like, if there is a larger misfit, we can still process the data post-inversion. So we can do post-inversion removal of bad data points. This is done by using another small module, which is opened by using this command in the extra submenu, remove data with large misfits. So in this module, the misfits for all our data points are plotted here based on the geometric factor. And as you can see, for large geometric factors, as it is common, there are quite a few of the outliers. Also, often the very first electrode spacing will show larger misfits because of the high variations in resistivity in the near surface. So here we can remove a few of the data points that are above some cutoff limit. So the program suggests the cutoff limit at 2.6, but you can modify this by moving these sliders here, or just input a value. And by clicking on this button, we will just delete these points that have the large misfit, like so. And here there is a tip from the program that we removed 18 data points. Now let's open another data example. Well, here I want to talk a little about the inversion mesh design. So by entering this program setup dialog box, we can display our mesh. And the mesh that the program suggests is good enough for solving the forward problem. It is dense enough to get an accurate solution of the forward problem. But for inversion, this mesh doesn't correspond with the real resolution of the method, because the resolution of the method decreases significantly with depth. And as you can see, the size of the cells in our mesh, they don't change that much with depth. This leads generally to over-determination of the inverse problem, which means that the number of parameter cells is much greater than the number of actual data points. In most cases, the inversion algorithm can deal with that without much problems, but sometimes this can lead to some undesired effects, like oscillations in the areas of lower sensitivity and such. So this is not absolutely necessary routine, but it's still recommended to bring the mesh into accordance with the real resolution of the survey, which typically will result in a more stable and reliable solution, although the misfit, the inversion misfit might increase So this can be done by grouping the cells. In the model tab of the program's setup, when we activate this checkbox for cell grouping, using this table, we can group our cells both in vertical and horizontal direction. Usually we want a little bit denser grid at the very near surface, again, because of the high variations in the resistivity between the electrodes. But say starting from the third layer, we can group every 2 cells. And doesn't appear to be changing for some reason. Oh, I know, it's because I have the model display as a contour section. So I'll just go there again. I'll just repeat this procedure. So starting from the third layer, we will group every 2 cells, and you can see how it changes right away. And for example, maybe starting from 12th layer, we can group every 4 cells like this. And also we can group these cells in the vertical direction, like this. Again, this is not strictly necessary, but it's a good practice. So let's run the inversion on this data set. Now, a few words how we can improve our inversion results. The best way to do this is to use some prior geological information about your survey site. And for example, if you have some boreholes within the limits of your survey line, we can set a priori boundaries and use them as constraints for the inversion. This is done using this set boundaries toolbox. And the way it is done, you can just plot these boundaries right here in your model space, like so. I will plot a couple of boundaries just to see how the inversion model will change after we run the inversion with these boundaries. So let's run the inversion. And as you can see, applying the a priori boundaries typically result in more contrasting boundaries or stronger gradients between the layers. So this is the best, probably the best way to use an a priori information to constrain your inversion results. And I'll show a few options how to present your data. In the program, there is a borehole editor using which you can plot geophysical logs or borehole columns in your model. For the geophysical logs, you have to import them from a file, for example, LAS file. And for boreholes, it is very easy to plot boreholes right here using this borehole editor. For this, we just need to add a borehole, specify the number of layers for the borehole column, and then set up the depth for these layers, something like this. And then we can use these hatching patterns to indicate the geology. There's quite a number of presets for the hatching, or you can use solid colors for this as well. You can place this borehole any place on your model. You can give it a name, so it will appear as a label on this borehole, and you can even specify the inclined boreholes using this input box for the angle. And once we created this borehole, it will appear in our modeling space here. Another option is a full geological editor. So this editor is used for the geological interpretation of the resistivity inversion model. It works very similar to the polygonal modeling modes, where you just plot your polygons like this. I'll just, again, I'll plot a couple of them, something like this. And after creating these polygons, we can also apply some patterns indicating the geology. And again, you can use some solid colors as well for this. And then you can remove this background and show only the geological interpretation for your survey line. And after that, you can save this image as an image file. Also, here you can plot lines like this if you want to indicate some faults or something like this. And finally, another option is just to plot some objects right here in the model space using this toolbox here. Again, you can plot polygons like so. You can plot lines, and you can input some text here as well. Like this. And finally, if you want to export this, the whole workspace, there is this print preview dialog box from which you can either save it in a PDF file or as an image file. There's this table here where you can input your project information. And for the model, for the inversion model, there is a number of exporting options. In the import-export submenu, you can export your model into a CAD file, DXF file, or you can just export it into the Surfer program. Also, a lot of visualizing options here are customizable. For example, you can play with the color scale. Just give me a second. You can play with the color scale. You can choose either from the preset color scales, or you can configure your own color scale here. You can choose to show ISO lines and labels like this. And if you want, you can, in this dialog box, you can only show one specific isoline or several isolines. Also, the axes are also customizable. You can change the increment for your axis. You can change the font, or you can plot the grid lines and other things. Even these electrodes, they can be modified. For example, if you want to use a different icon for your electrodes or a different color, like this. And finally, probably the last thing I would like to show you is how to present your data in the 3D form. So
hello, Ilia. Couldn't hear you. Hello. I suppose Ilia missed somewhere, so we're waiting when he connects again to us. There is maybe some technical problems. Oh, he asked to wait 3 minutes because it's some problem with electricity. So please wait, and I will answer your questions during he away. So we have several questions in the chat box. Some of them already answered there, but there is a few new. First one is, does software work with IP data? Yes, software work with IP data, and it's not only traditional IP, it's also call, so it's full waveform inversion for IP. But in this webinar, we do not demonstrate it because it can take a long time. So, and next one. Hi, can you export DOI information on the figure? Okay, we have a special parameter DOI, which was suggested Douglas Oldenburg, and it can be calculated in software. So every pseudo section or model section can be exported in text file. So yes, you can export it. Next question from Franklin Medina, but I couldn't understand. Information of 2.5D. Yes, 2.5D is is a special term for electromagnetic and seismic. That means that we have a 3D source and 2D geology. I hope it's the answer to your question. Okay. Next, we have a question from Thomas. Hi, Alex. Is there a possibility to show in the resistivity section a numerical representation of the fit of the model to the data? It's actually, you mean misfit of data or fit? Misfit of the data, yes, it's possible, and maybe Ilya can show it later when he back. But this just a difference between two pseudosections. Yes, you can plot it. There is options for plotting different data derivative and different model derivative. Okay. Next question from Itamara. She asked, how can I fit the result from ERT OEP in upload Imagen? Actually, I don't understand what does it mean. If you need any result from resistivity or IP and you need it upload, no, sorry, couldn't answer this question, don't understand. If you give more details, what exactly you would like to do with software, or what you want to export from software, I can answer the question. Oh, you mean it's about background? Yes, you can upload any image. It can be seismic image, it can be geological image, anything. So we have Ilya with us again. So give me please 2 seconds. I will try to make him. And we can continue now. And sorry for these problems.
Hello, everyone. Again, I apologize for my disappearance. There was a power outage in my area. So let's continue with this presentation. Let me share the screen again. I hope I'm sharing now. If not, please let me know. So last thing I wanted to show you is how to present survey results in a 3D form. This can be done if you have several parallel or crossing lines in your survey area and you want to compare them in the 3D form. So let me open another project here. This is currently, this project has only one line, which was already inverted. And to go to the 3D visualization mode, we use this command, 3D fence diagram. And this is the 3D module of the program. On the left here, there is a table that contains all our available models to display. Currently, we only have one model. And as you can see, the coordinates, the UTM coordinates already input here in this table. And on the right here, this is the plan view map of our survey. Currently, we have only one line here. So I will add a few more lines. To add more lines, first, of course, you need to process these lines separately and then save them in save the models, the inversion models, in the mod2D format, which is the proprietary zoned format for storing model data. So I will add another couple of lines. And as you can see, these lines, they also have the UTM coordinates already specified, but if not, you can just input the coordinates right here in this table. So we have the total of 4 lines, and now we can go into the 3D display mode. So our lines here are plotted with topography in this kind of 3D cube, and you can rotate this cube any way you want. And another option is to plot horizontal slices. These slices will be like horizontal surfaces that are interpolated between our survey lines. And you can plot these slices at any depth that you want, like this. And another option is to upload a satellite image. The program will look up a sat image in the internet using the UTM coordinates specified before. So to upload this image, you need real, actual UTM coordinates. So this is our plan view map with the satellite background, which can also be displayed here in this 3D form. So I think this is it for the presentation. I showed pretty much what I wanted to show. Sorry for the interruption a few minutes ago. And now Alex and I will answer some questions if we have any. Unfortunately, when I was away, my chat history was also deleted, so I don't see any questions in the chat. So Alex, you will have to take care of this.
Thank you very much for very good presentation, Ilya. During this pause, we discussing question that we received in the chat box. Now I think I can allow to all turn on microphones and ask question directly. No, I can see this option.
Let me see how we can do that.
Oh, yes, I found. So if anybody have a question, you can just turn on microphone and ask. What I already see 2 questions from Enzo. Could you give some your suggestion on the kind of inversion to use? I always recommend to do a common version with different settings. Why? Because it's more stable algorithm from all gradient inversion suggested by software. So there is several settings for this kind of inversion, and result can be very different sometimes, because sensitivity especially in the bottom part of model, because sensitivity is very low, and you can from one hand it's good because we can incorporate our a priori information. From another hand, of course, it's not so good, because we can have different models from one data set, but it's it's like a classic in geophysics. There is a lot of models and all of them wrong, but some of them useful. So this principle we're trying to use in our software. So you can use many settings for inversion to make your model much close to your geology. Okay, next question. In the free
Alex, I just wanted to say that participants can now unmute themselves because before this option was not available. So if anyone wants to ask a question, just unmute themselves, please.
Thank you.
Sorry for that. You want to continue with this?
Actually, we have two additional questions in the chat.
Okay,
yes.
Let me handle this. In the 3D, there are, I see you put the UTM coordinates, but how we input the elevations. The elevations are input on the processing stage. When you process individual survey lines, you can input the topography and then store these inversion models with the topographic data. This is how it's done. And another question is, could we do a 3D interpolation of interpreted geological layers? Well, since we cannot really mark these interpretations so that it can be interpolated, we can only plot lines or layers on the in the modeling space. So the answer to this will be no. There's no interpolation for the geological layers.
I have one private question. Can we keep borehole data in 3D model? Yes. All our borehole data will be plotted in 3D, so it's no problem. But I would like to add something to what Ilia said about 3D interpolation. Because people used to trying to interpolate just a few profiles. We do not use gridding options in software because it's very big responsibility. If people trying to analyze all this interpolation image, because if distance between your profiles is very big, what you can interpolate between these two lines, it's just a fantasy. But you have a possibility to export your multi-profile data to 3D grid, and you can open it with Voxler software or another software, but this will be already your responsibility, not our responsibility. Thank you. I think Itamara wanted to ask us a question.
Yes, please, you can unmute yourself and ask the question. In the bottom left corner of the Zoom window, there is like a microphone icon that you can use to unmute yourself.
Okay, we have another question from the answer again.
Hello, can you hear me now?
Yes, please.
Okay, thank you. I have a very specific question. So let's assume that we did a first measurement in one area that we know we have clay. And then in the middle of this area, we, let's say we drew a hole and we put cement with salt to stabilize the clay. And then we want to do a second measurement in the same line, in the same area. So my question is, in the second measurement, before the inversion, should I take make like a borehole on the data to do the inversion, or should I let the inversion run free?
I'm not sure what you mean by making a borehole, but it's probably better to just run the inversion on the second data set to see how the salt affects the measurement results.
Okay, so I just let run free, like I have not put like a hole over there with salt. Okay.
Well, it's always better to see how the inversion algorithm will perform without adding some constraints to it. And then usually when you have something very conductive, like the inversion will smooth everything over the large portion of your inversion model. So after that, you can try to constrain using maybe the a priori boundaries, try to constrain this object in like isolated location like this.
Okay.
I'm not sure why people are saying that they cannot unmute themselves. Let me check this again. Okay, I will just try to unmute some people directly. Give me a second. Give me just 1 second. I don't see that person. Okay, I see. So, Anso, if you want to ask the question, you probably now can unmute yourself.
Do you hear me?
Yes, we do.
Okay, I'm sorry, I tried to write on the chat. I have to ask about model and data histogram. How we can use this option?
Modeling and data histogram. I'm not sure exactly what you're talking about. Can you specify what kind of histogram?
Sorry, Ilia, I already answered it in the chat box because we have here two options for plotting model and data histogram, like a distribution of model parameters versus number and data parameters versus number. Sometimes it can be useful for analysis of your inversion, because shape of this distribution should be similar. Not so similar, but it should be similar. So you should have the same numbers of peaks in this distribution. In this case, it's a very good indicator that everything all right. So it's just a statistic parameter. Sorry, I think I answered your personally in the chat. Maybe you didn't receive it.
So there's another question from Thomas. So can we see the distribution of the misfit on this section? Yes, there is an option to do this, and I'll share my screen again. So for the misfits in the data sub-menu, first thing off, probably one important thing that I forgot to tell about, you can display resistance values instead of resistivity. This can be used to assess the expected signal level. And yes, here by checking this checkbox here for data misfit, in the calculated pseudo section, you will see the distribution of the inversion misfits. I hope this answers your question.
And one more option, I already trying to type it, but There is one more options to display, to plot this misfit in quality control model. There is option, it's called misfit, and you will see theoretical versus observed data. It's right in settings, right? Misfit, last one.
Yes, this graph is the distribution of the misfits based on the not sure based on what the plot is. Probably geometric factor, or okay, it's calculated observed data versus calculated data. That's another option to display misfits in the form of graph. And also, no, this is just calculated data. So it's either the pseudo section or this the graph in the quality control module. Can we add the misfit section together with the observed, calculated, and inverted model? We can only display 3 sections. So it should be either, so yeah, either the calculated or observed or the misfit or the model. So there's no way to plot 4 sections, I'm afraid. Although Alex might have another view on this. Alex, do you want to specify how we can plot 4 sections?
Section is only options for buffer, so you can plot.
Buffer, yes, absolutely. But buffer is actually a good option. So here in the buffer, you can save, I think it lists 5 models here, but you can, I think you can save all 5 by display only 4 of them. So you can save these data into the buffer and then open and visualize them in one window. That's right.
Here is a request to show again how to see
misfit. I'll share my screen again. So the for the pseudo section here, we go to the data and data misfit. So instead of the calculated data, it will show data misfits. And for this graph, this is done in the quality control module, which is opened from the options menu, the top command here. In the settings, instead of plotting the data grouped based on the electrode spacings, you can choose this option for a misfit, and this graph will be plotted here.
I think there is no more questions.
Yeah, I guess if anyone else wants to ask a question, please let us know. I'm not sure why the unmuting option doesn't work here. Seems to be only working when I directly ask people to unmute themselves, which is weird. And so saying that in his version of the program doesn't have this option, so it's probably was updated too long ago. I guess maybe this is one of the latest options. Yes, as Alex saying that this was only added recently, so you might want to discuss the upgrade of your software with Alex later.
Okay, thank you very much to all who participate in our webinar. It was a pleasure to us, and especially many thanks to Ilia for the great presentation. I never can do the same. Such a good. So thank you very much.
Thank you.
And see you soon.
Yes, thank you, everyone, and see you again in another webinar. Thank you.
Yeah.